Hi everyone. This series of videos is going to take you through most of the examples on page 12, although I'll make the disclaimer that you probably don't need to watch these videos in order to do these questions. These are all review of the videos that you would have seen in the week 32 Wednesday and week 32 Thursday lessons. So if you feel like you already understood the week 32 lessons, I don't think you need to watch the videos for today's playlist at all, and you should be able to do all of page 12 and all of page 13 without watching any of them. The videos today and the videos for the page 13 playlist are really just meant to walk you through if you don't feel like you understand, but a lot of what I'm going to go over in this playlist is basically just a rehash of what I've already talked about in the week 32 materials. So if you want to just save yourself some time, you can probably get it done faster by simply working on page 12 and having the answer key open rather than having these videos open. I tend to explain things really slowly and in a lot of detail, and I know not everybody needs that. So if you personally don't feel like you need it, then skip this entire playlist, because this is just going to be me repeating what I've already taught in previous videos. If you feel like you need some examples though, if you feel like you need some structure, then I'll do these questions just so you have the ability to learn it. It's your choice, and it's certainly something that you can decide for yourself. The only thing that I'll tell you that you'll need for these questions is a calculator. I like to use a graphing calculator, but any calculator will do, even your phone calculator. My recommendation though is if you're going to use a phone calculator, which is a good idea, make sure that you have it so that you can rotate it sideways and get the full scientific calculator with all of the options over here, so that way you can use some of the parentheses and the exponent features, especially if when you have it rotated portrait like this, you don't always see all of those things. It's kind of a pain to have to push the extra button. So that's why I recommend, if you're going to use a phone calculator, use it sideways so that you have things like the power button visible. If you have a regular calculator like this, that's also fine too. Any calculator is okay. You can even use Desmos. You can just go to desmos.com/calculator and you can type into Desmos. And even though it's a grapher, it does also do basic calculations. So lots of examples. Now, in question number 1, the question itself has lots of words. So just as I've talked about in previous videos, I think the best idea is to highlight what's important about the question, the words that seem to be crucial, and then we'll go through and do the math. So for example, in question number 1, we've got this bakery debuting a new triple chocolate muffin. She expects to sell 100 muffins initially. And I know that word initial is important because that's what we call the initial value. So I'm going to highlight the number 100, and I'm going to highlight the word initially to show that those two things go together. And expects to sell an average of 15% more each week. So I'm going to highlight that phrase in a different color. 15% more. That means we're going to increase by 15%. Remember, we saw on page 10 and page 11 problems with words like increase and decrease. And specifically on page 11, we actually made a rule for ourselves that to figure out a percentage of increase or decrease, we take 100% of what we start with plus whatever percentage we're increasing by. Or if we're decreasing, we would minus by whatever decrease percentage we have to deal with. So I'm going to copy that little rule for myself so I can remember it, that we always need to focus on 100% plus or minus. It depends on increase or decrease, so that's why I write both. The percentage that they tell us in the question. So since this question gave us a 15%, that's tipping me off that that's the percentage that they are referring to in that rule. So even though it seems strange to do this, I'm actually not going to start with question letter A. I'm going to start with a little bit of side work here, and I'm going to figure out this thing that we call the multiplier. That percentage plus 100% thing, that's what we do to find the multiplier. So again, I'm going to make a little note to myself, just in case it's been some time since you've thought about this. This is how we get a multiplier. And again, I'll just kind of highlight it so that way you can keep this for reference. You can refer to it in notes You can even write it on a separate sheet of paper if you keep notes somewhere near you, so that way you can refer to it. This is how we're going to get a multiplier. Now the first thing, and kind of obvious thing, is that if I have a multiplier, that means I must be dealing with a geometric sequence. Remember, arithmetic is when we have an adding problem, an adder. But since I'm going to use the percentage as part of a multiplier, I know this is going to be geometric. So I'm going to circle the geo there to prove to myself I already know this is geometric because it's a percentage. Percentages give me multipliers, and that tells me for sure this is going to be geometric. Now, the question is, what would be that multiplier? So let's think for a second. We start out with 100% of our muffins. It's not actually because it's the number 100. We start with everything we've got. She's going to sell all of the muffins, all 100% of them. Then she's going to increase by an additional 15%. So I'm going to think to myself, I start with all 100% of the muffins plus another 15% more. So that means she's going to sell 115% of those muffins every single time she makes that increase. And 115% needs to be converted to a decimal in order to get a multiplier. 115% currently has a decimal right after the 5. So if I move 2 places to the left, that's how we always convert a percent to a decimal. We end up with 1.15, and that's the number that we call the multiplier. It doesn't actually ask us for the multiplier in any of these answer spaces, but the multiplier will show up in 2 different usages. One place that's going to show up is in the equation. So I'm actually going to jump a little bit to letter C because the multiplier is part of the equation, and on previous pages we've done a lot of these equations. If you want to flip back to either page 11 or page 10 or even page 9, we did lots of problems that had these equations. And the equation, I even wrote a formula here on the bottom of page 9 so I could, page 10 so I could see it here. This is the equation for a multiplication or a geometric sequence. This is what I want, and I'm going to copy that here. So in case you need it, or in case you need a refresher, you can go back to the week 32 videos, go back to page 10, see if it helps. But we need an initial value and a multiplier to the power of n to write an equation. And that multiplier that I just found, that must be the m in my formula. So that number, 1.15, must be the number that I need for that inside of the parentheses. The initial value was the number that they told me in the question she initially started with. She initially started with 100 muffins. So I can copy out my equation because I have this information. I initial is 100 times, parentheses, m for multiplier, I just found that's 1.15 to the power of n. Now that equation is going to allow me to do 2 parts to this question. I can do question letter A now because I can very quickly generate all of the terms in the table. I know that initially my table will start with 100 muffins. So that's what we call the 0 term. Initially is the 0 term. And I know to get the next number in the table, I just need to multiply by the multiplier, 1.15. So with my calculator, 100 times the multiplier, 1.15, gives me 115. And I know that I can make fast work of this table because every term is just going to be multiplied by 1.15. So I can take 115 times 1.15, and I can get the next one. Now remember, the question is about how many muffins we sold. The next answer is 132.25. That's not really a practical number of muffins. Like, I'm not going to buy a quarter of a muffin when I go to a store. That doesn't make sense, and that's also kind of tacky. So let's just round down. It says round any partial muffin sold down to the nearest whole muffin. This is like 132 whole muffins and some crumbs left over. So I'm just going to call this 132 muffins. I'll use the decimal as part of my calculation, but I'll just round it down. So when I do the next one, if you have a handy calculator like that one that has buttons, you could just press times and it copies and pastes your previous answer. Times 1.15 to get the next term. That's 152 whole muffins and then some decimals that represent some crumbs. So 152 muffins times another 1.15. That's 174 muffins plus some decimal crumbs. Times another, 1.15. That's 201 whole muffins and some crumbs. And then times another 1.15 is 231 muffins and the decimal crumbs. So that makes life easier because now I can just quickly get all of the numbers and my calculator's doing most of the heavy lifting. I didn't have to do a whole lot by myself. In question letter D, it says how many muffins will be sold 1 year after they debut. Here's the problem. I've only gone to 6 weeks. A year has 52 weeks in it. So the idea that I'd have to keep going and going and going 52 times to try to get eventually to that part of the table, that sounds tedious. Even with a calculator, I don't want to keep typing times 1.15 times 1.15. That's going to get so old so fast. So this is where the equation is helpful. Remember how 1 year is 52 weeks later? Well, the n in our table, remember we call the top row n and the bottom row t of n? The n in the table is just the number of weeks. Remember we have an equation? N is just the number of weeks. So if I want to make my life a little bit easier, I could say to myself, hey, wait a minute. 1 year, that's 52 weeks. If the equation has a spot where the letter n is, I can just plug 52 into the equation where that n is, and I could make the equation do this for me. Instead of me multiplying myself 52 times, that's what the equation's doing. This is saying, hey, multiply 1.15 52 times. That's what exponents do. So in my calculator, I can type 100 times 1.15 to the power of 52. 52 weeks, remember, is 1 year. And then I can get the number from the calculator without having to worry about doing all those individual calculations. That means that if I kept this pattern going, I would have 143,313 muffins and some crumbs left over. So the idea that the equation can do the heavy lifting for us is also very helpful. Between a calculator to do some things and the equation with our calculator to do the rest, we can make much easier work of these questions. Here was the key. We had to know the equation. We had to know the initial value and the multiplier so that we knew the pattern. Once we knew the pattern, the calculator can do the rest. As I said at the beginning of this video, you might not need to do the rest of these questions with a video. If you kind of know now how to use equations and how to generate tables and how to use your calculator, then I don't think you need me to talk you through question number 2, but I'll leave you up to make that decision for yourself. If you need a video to walk you through question number 2, the next videos in this playlist will help you do that. If you feel like you're good to go, you can stop watching and finish question number 2 on your own.